This is our final keynote, and those of you joining online, thank you so much for being here. I have to say, I just went down for the coffee break, and as I was going down on the escalators, a gentleman, as we were turning the corner, said, "I've been coming to conferences for 30 years, and this is by far the best." So congratulations, everyone, for all the speakers, all the content, all the hard work. It's really wonderful. So now I'm delighted that this session, our final keynote, is supported by the University of Edinburgh College of Medicine and Veterinary Medicine. And I'm very happy to hand over to the chair of this session, Professor Duncan Astle.
Thank you very much. And hopefully you can all hear me at the back. It gives me enormous pleasure to introduce the final keynote of our meeting, and that is Professor Sue Gathercole from the University of Cambridge. Sue's work will be familiar to many people here because really it's foundational to what we know and understand about cognitive barriers to learning. And there are very many accolades that I could use to describe Sue, but if you want to know about them, I suggest you just Google her, because it will be far quicker, and I know Sue doesn't enjoy long introductions. But I thought that given that I've known Sue for almost 20 years, that I would just tell you one quick thing that I really admire about her. And that is her fierce intellectual curiosity and humility. And I think it's something that's really rare of people of her standing in our field. And in a way, I think it's sort of her superpower because it allows her to ask sometimes very radical questions about what we think we know about development. And a really good example of that is the CALM study, which Sue started around 10 years ago, which really questions some of the most fundamental assumptions that we make about neurodevelopmental diversity. So without further ado, I will hand over to Professor Sue Gathercole.
Thank you very much, Duncan. What a kind and generous introduction, no less than I'd expect from Duncan, of course. I knew Duncan when he was 19, when he was an undergraduate, and he was fiercely smart even then. Well, it's great to be here. It's a real honour. I'm so delighted. The sponsorship from the university, from the University College, is just great. But really, it's just provided a great experience for me being here and being part of this particular show. So thank you all for staying on. I feel like it's a Friday, but obviously it's not a Friday. There's that feeling, but it's still great that you're all hanging on and delaying your travelling home, so I appreciate that. Let me just say a little bit about myself. So I'm a cognitive psychologist through and through, really. So my main interest has been in memory and learning throughout my career. Across time, probably within about 5 years of starting research, my PhD, and then a couple of years afterwards, I realized that really what I was most interested in is not necessarily using experimental paradigms, even though I quite like them. I'm extremely interested in theory. But really what I wanted to know was, in the case of the memory system of particular interest to me, which is working memory, I'm going to say something about it, I wanted to know what it did for us. What practical benefits do we have to have this particular memory system in our everyday lives? And I guess what I would really like to do is to make a difference. And it's just been, it's the corny word, but it has been an incredible journey progressing through this field as the field moves along with itself. But particularly working with all of the different professionals and individuals that you come into contact with if you are interested in memory and learning and how it might go wrong sometimes or how it might be compromised and how you might help it. So I'm going to sort of talk about a transdiagnostic approach to research, which I think is hard, but I think it's absolutely vital for the field, and I think we're at the point where it's actually fairly well recognised, but we actually need to change our research paradigm somewhat, or we need to make sure we hold steady to the new developments. So I'd like to say a bit about that as I go through. There are also some other lessons that I've learned that I'd like to share with you along the way, and they've all come out of the partnerships that have emerged in this research. So that's what I'm going to do. I'm even going to try and keep on time. So This is a picture from the CALM study that Duncan's just mentioned, and I am going to talk about the CALM study. That was a summer day that we had where we invited all our participants into the lawn at the back of the Cognition and Brain Sciences unit for the day, and we had a lot of fun and ice creams. Okay, so I'm going to start off with working memory. Really, it's a sort of worked example, I hope, of why we need to go in the transdiagnostic direction in terms of research and understanding. What I mean by transdiagnostic is not think in terms of particular categories, silos, diagnostic categories, but try and understand really what's going on under the bonnet. In many respects, I think it could turn out to be simpler than what we've got at the moment. So working memory, this system that I've been so fascinated with, it's that, many of you will know about it, but it's the memory system that we have that holds the current, the present, for a short period as we move through into the future. So it's almost not like a memory system at all. But so if I stop speaking now, you'll have some recollection, some ringing in your ears of my voice, of what I just said. And you might be in a situation where you have to remember that information while you go about engaging in some daily activity. So a good example actually is if you're navigating in an unfamiliar place. I've been up and down all sorts of wrong turns in Edinburgh. Imagine someone gave you some instructions and you've got to hold those in mind while you're actually navigating, crossing the road. So there's other things going on at the same time. And that's what this memory system does for us. So it's a mobile mental workspace or notepad that we're able to use. So it's really useful. And it may be one of the most useful things that distinguishes our species from others. Having this, it's volitional, so we choose to use it, but it's really flexible. We can use it for all sorts of things. So that's the upside of having a working memory. We all know it, we're all working memory users. The downside is it's fragile, so it fades quite rapidly. So if we just don't actually pay attention to what we're trying to remember, it will actually fade away and we won't be able to remember it. It's not something we can then think hard and reconstruct. It's a memory that just goes, and it's unrecoverable. So there's hazards. The hazards are greater for some individuals than others. So the capacity, you can't really measure it in terms of any sort of standard units, but generally how much you can hold in mind while doing something else, but still holding on to that critical information, varies quite a lot between individuals. It varies in children. It tends not to, although working memory capacity actually develops over the childhood years, and I'll show you that in a minute, your kind of relative ranking in terms of working memory capacity compared with your peers, your age peers, you tend to keep track with them. So you tend not to, it tends not to be the case that you have fantastic working memory at 2, well, you can't measure it at 2, actually at 4, but by 6 you've got poor working memory or vice versa. So it's actually relatively fixed in some respects. It has implications for education, and that's what I'm going to be talking about. So let me just show you what happens to working memory across the childhood years. So it actually doesn't matter what's on the vertical axis here. It's just scores. It's a working memory score. It's not really, it can be converted into a capacity measure, but someone who's doing well in terms of the working memory demands of a task will get a higher score than someone with a lower score. So what you can see, we've got age in years at the bottom. So we tested lots of kids at each of these different age groups. And if you take the middle line that's joined up, then what you can see is that there's a fairly steady increase in working memory capacity over the childhood years, between 5 and 15. And by this measure, it just about doubles, or it increases by about 2.5. And that's actually probably true for most measures of working memory. So younger kids have less of this capacity to hold information. They still have the capacity, but they can hold lesser information than older children. But what I really want to draw you to your attention, and I think this is really important practically within the classroom, is that children vary even at the same age. So you'll see there are 2 bars. There's a bar running top to bottom for each of these different age groups. And the child at the top of one of these bars. So look, I'm now highlighting the top of that bar for the 5-year-olds. Has that score, and the child in the same class, as it were, who has the lowest score performs at this level. So you have really, really wide variation, even within the same year group, of children in terms of how much information they can remember or hold in mind to guide their ongoing actions. So let me just give you some way of quantifying that. So let's have a look at the 8-year-old data. So we look at the working memory capacities of 8-year-old children. Can't see my pointer. Probably doesn't matter. It's probably because I'm holding it the wrong way around. It's definitely because I was holding it the wrong way around. Right, here's the 8-year-olds. So that's the average, around 12. The kids who are doing at the top 10% for their age group are performing there at the same level as the average 12, 13, 14-year-old. So they're very mature in terms of their working memory skills. And let's have a look at the children at the bottom 10th centile, the bottom 10% of their distribution for their age group. And what we see is that their working memory capacity is appropriate for 5-year-olds. So what that means is that in one of these, in a year 3 class in the English system, we've got the whole developmental age range of working memory capacity represented in one classroom. So it's a big issue. Does it matter? And turns out it does matter because it's really important for learning. So of all the measures that you can give, the sort of cognitive assessments that you can give of a child's abilities, the one that will probably predict and certainly be associated most highly with measures such as the children's maths attainments and the children's reading attainments are working memory measures. So it's not something you can train. You can't, and I'm someone who's spent quite a lot of my life trying to find ways of training and sort of boosting working memory skills. So it stays relatively invariant. I'll talk a little bit later about what that means in terms of how we work around those problems in the classroom. So we've shown, lots of people have shown in lots of different ways that working memory capacity is really closely linked with academic attainment. Now, as someone who's a cognitive psychologist interested in this working memory system, this has become really exciting to me. This is when my kind of research really, for me, lit up, trying to understand exactly what's going on. So we find very close links with learning. I'll just give you a couple of examples here, just in case you want to get some idea about the size of the difference. Looking here at the Key Stage 2 national curriculum scores in England, which are taken when the children are 10 or 11 years of age, and they're taken universally across all state schools. And children are classified as at one of 3 levels. This level, the intermediate level, which is average for the age, and about 67% of children will fall within that level. These are children who are failing to get to the levels you might expect in terms of maths in this case, and these are children who are exceeding by quite a long way what we would expect. Now, up this axis here, I've got working memory score, and this is a score that tells us how far an individual is away from the average for their age group. And this red line here, can you see it intersects at 100? So a child who gets a working memory score of 100 on this particular metric is bang on what you would expect for their age. So have a look at it now, and what you can see is that really working memory scores sort of track mathematical attainment within this particular age group. So the kids who are average in maths are average in working memory. The kids who are low in maths are low in working memory, and they're as low in working memory terms as they are in maths terms, and the kids who are doing really well in maths are particularly high performing. So these are actually big differences that are found. Is it just maths? No, it's not. So now we're looking at national curriculum English scores, and that taps reading, single word reading, reading comprehension, comprehension of text, and also writing. And so it's quite a general composite measure. And we find exactly the same relationship. So we're looking at the average of the children. This is the group who perform averagely, below average, and above average on these English assessments. and we find that their working memory capacity scores track upwards as the ability group, we progress through the ability groups. So they're quite general predictors. They're also pretty fast and easy to administer, actually. So it's somewhat surprising. So we got fairly excited about this. There'd been plenty of evidence along the way, but particularly when we started showing that there were meaningful links with the meaningful data that schools were collecting that they were using to track and compare the performance of their children. So that seemed really important to us. We kind of trepidatiously started stepping out of the laboratory, as it were, the testing environment, and started speaking to groups of teachers, speech and language therapists, educational psychologists, anyone who listened that was interested in how kids did, and started talking about this. And I was pretty unconfident. I didn't have much experience of the classroom myself. I don't come from an education background. And they were always really nice, the audiences. They listened attentively. They clapped at the end. And then they always asked 2 questions. And this is my first lesson, which is listen to the professionals and then try and do something about what they tell you. The first question is, what do these kids look like in the classroom? You know, how do we recognize these children? We can't go, clearly it's not feasible for everyone to go about administering working memory assessments. What are the consequences for their classroom functioning? And it's just to our enduring embarrassment, we weren't able to answer that question. The reason we weren't able to do that was we'd go through and we'd test lots of different children on the measures, then we'd get back to the lab and we'd score them up, and then we'd enter them into the spreadsheet, and then we'd look at the statistical relationships between how well they were doing in school and their working memory scores. So the individual child wasn't in there. We'd never known, even when we were testing the child, whether or not they were a child who was doing really well in these academic areas, or that child was possibly struggling. So that was lesson 1, and we have tried to do something about it, and I'll say something about that. Lesson 2, the question 2 was, okay, so I'm fairly convinced working memory might be important, so what should we do about it? Well, we didn't know about that either. Partly because we hadn't spent any time actually looking at the children and seeing how they were functioning in the classroom, so we couldn't really gain any practical insights into how they were functioning. And although there was already quite a large research literature, it was really just charting. No one was actually saying how it was. Was there a causal relationship? You know, what was working memory doing? So we really shifted paradigm for a period, and it's this paradigm shift really that's fueled almost everything else we've done, directly or indirectly. So we went and sat in classrooms and observed children in the classroom. We focused on children. We tested first for working memory ability, and we observed children. The observations were blind, who either had low working memory or who were completely age-typical in terms of their working memory. And we observed what they did when particular events occurred in the classroom, any difficulties they had. So we did that for a relatively small number of children for quite a long time in the primary school classrooms in the ages 5, 6 and 7. So what did we find? We were worried we wouldn't find anything, but it turns out that wasn't a problem. So I'm ahead of myself. So to understand why working memory is linked with learning, we need to understand the individual. We need to know what's happening in the classroom, not just pursue statistical links. So the first thing we saw, highly consistently, was the children with relatively weak working memory skills exhibited problems in following instructions. We hadn't actually, in our naivety, realised what a working memory heavy environment the average classroom is. So instructions make the world go round often within the classroom, and telling the children what they're going to, where they need to go, in what sequence, what they're going to do, what they need to use when they're doing that, when to finish, what to do when they finish. And in another project, we've actually collected, recorded lots of instructions that we've heard in the classroom. and got undergraduate students to repeat them, actually. And quite often, the undergraduate students have problems repeating them too. So some of them are quite complex, these instructions. So here's an example. This is for a 6-year-old we were observing who had a low working memory. The teacher said, put your sheets on the green table, arrow cards in the packet, put your pencil away and come and sit on the carpet. John moved his sheets as requested, but failed to do anything else. When he realised that the rest of the class was seated on the carpet, he went and joined them, leaving his arrow cards and pencils. So these are actually highly typical. This is a highly typical profile in the low working memory group that we didn't see in the kids who had age-appropriate working memory. So he started the instructions, which is interesting because it suggests that he listened. So it isn't that he was just not paying attention. But then he lost information about what to do next, and then he caught up at the end, but that was only because the other children were sat on the carpet. So that's quite a distinctive pattern that we see for instruction following. We also saw that our observations that many of these children had problems in sustaining attention, keeping focused attention to a task. And that's really important because often they have to keep in mind the goal, the target, what it is they're doing, what it is they're looking for. If they're engaged in a sort of a Where's Wally type visual search task, almost anything, they need to know what it is they're doing. So here's Adam, 5-year-old. He struggles to maintain attention. This is our case notes, observation notes, particularly during whole class teaching when the pupils join together on the carpet. He sits directly in front of the teacher, so she's made sure that he does so, and he's frequently prompted to sit correctly and pay attention as he regularly fidgets, looking around the classroom and distracting other children near him. I think anyone who's spent time in the classroom will actually recognise this kind of entirely normal and within the context of a classroom behaviour from a young child. So, but these types of problems in keeping on task are much more common in the low working memory children. So, when we got these findings and we started talking about them with teachers and educational psychologists, what they often observed was that very, very similar problems are seen in children with ADHD. I think I might just have I've lost, oh yes, I've actually lost my nice slide. Okay, we asked teachers and also the children what their experience was. No, we asked teachers how those particular children function in the classroom. And what they would typically say is, for example, oh, well, it's in one ear and out of the other, or he or she doesn't listen to a word that I say. It's really hard to get them to pay attention. So very much the description corresponded to a failure of attention. Interestingly, though, in our observations from the children, we also saw children's explicit reflections of the fact they couldn't remember critical information. So they would say, I forgot. They'd ask for information to be repeated, and they'd quite often turn to the child next to them and ask them what they had to do next. So there was some degree of mismatch actually between what was the teacher reports, which seemed to be almost a consequence of the working memory failures, which is that the children couldn't hold in mind the particular details of what they were supposed to be doing. So all they could do was something else, blank out, daydream, fidget, perhaps be distracting with other children. Whereas the spontaneous verbalizations of the children suggested that actually they had just forgotten. So it wasn't a choice not to pay attention, but they'd forgotten critical information. So on reflection, in discussion with other professionals working with children, particularly children who they might actually diagnose as having particular conditions, it was suggested that this is very similar to in many respects to ADHD, in which these types of behaviour are also part actually of the defining features, the diagnostic features of that particular diagnosis. So many of you will know that ADHD typically is diagnosed on the basis of 2 different types of problems, inattentive behaviour and also hyperactive or impulsive behaviour. And checklists have been developed describing behaviours associated with each of these two different problems, dimensions of problems. So here are the inattentive behaviours in ADHD. Doesn't seem to listen to when spoken directly, is easily distracted, often loses things, often doesn't give close attention to details. So this started sounding fairly familiar. So we gave the same checklists to the teachers of children who we knew whether or not they had working memory problems or whether they were age typical. And what I've shown in red here is all the behaviours that were also shown by the children with low working memory. So they're looking pretty much like the attentional profile, the inattentive profile aspect of individuals with ADHD. So this seemed to us to be particularly interesting and a bit puzzling because we'd started off just focusing on working memory and now we're sort of touching with a particular diagnostic category that we weren't familiar with as researchers. But also these children didn't really seem to show very high levels of impulsivity or hyperactivity. So we looked a bit further and we carried out a study where we thought, oh, maybe the best thing to do is just to compare these two different groups side by side and see whether they are the same and in what ways they are the same. So we looked at children who have relatively low working memory, so bottom 25% in terms of their age group, and there was 50 of those that we looked at, and we looked at children who had proper diagnoses of ADHD. There was 80 of those children we looked at. To cut a long story short, there was a lot of testing, and many of the characteristics were overlapping. In fact, these two groups of children, although they presented differently in terms of their behaviour, they were more similar than different. So children with low working memory were inattentive, undoubtedly, by conventional testing instruments. They showed up as inattentive. They had low working memory. Well, we selected them that way. Most of them had educational underattainment, so they weren't doing particularly well in any of the benchmarks of progression for reading and maths in particular, and about 60 of them were male. So we didn't select them, that's just the number, of the large number of children we screened, 60% of the ones with the lowest working memory were male. If we now look at the ADHD group, we see that they're inattentive and hyperactive. Well, that's no surprise because that's the basis for the diagnosis. They almost all had low working memory, so that's sounding quite similar. Some of them had educational underachievement, so they weren't doing too well in schools. And actually, when you read about ADHD, often you'll read that it is associated with specific learning difficulties. And there was a large predominance of males. So more similar than different, really. That started seeming pretty puzzling to us. We certainly didn't have children who were completely distinguishable. They had many of their features the same and some features different. So really, in the case of the children with a diagnosis of ADHD, they were very, very much more hyperactive. So what does that mean? Well, our current classification systems or current ways of thinking about how children are doing in neurodevelopmental terms related to cognition don't really help us with this. And in fact, most of the children with low working memory wouldn't actually show up in anyone's radar in terms of having needs that require additional support. But actually, their educational underattainment was greater than those with the children of ADHD who attracted additional resource into school. So we felt this was worth sitting back and trying to understand. And what we discovered when we started reading around broadly, in particular within the area of psychiatry and what was going on in psychiatry at that time, this was around 2011, 2012, is that there's a very similar diagnostic paradox in psychiatric disorders that we seem to be seeing in the area of neurodevelopment, of the development of children's cognitive and behavioural abilities and behavioural control. So what we see in drawing on a really wide range of evidence, not just from our own lab, is a high level of co-occurrence between different developmental conditions of learning, neurodevelopmental conditions of learning. So what do I mean? I mean dyslexia, dyscalculia, specific language impairment, not so much with dyspraxia, but ADHD. So lots and lots of the symptoms are, the features of those different classifications are pretty much the same. So working memory, executive functions, and inattentive behaviour are pretty much hallmarks, on average, of each of those different groups that I've mentioned. Within conditions, though, so for example, if you just look through the lens of children with specific language impairment or dyslexia, then you find huge variability between different children. And if you look at their cognitive profiles or their behaviour profiles, sometimes you won't find any single feature that all of the children within that diagnosed group show. So apart from those associated with the diagnostic criteria, so how they're doing in reading or how they're doing in language in terms of standardised assessments. So we have all these characteristics, this jumble of characteristics that seem to be slewed across lots of different learning-related neurodevelopmental conditions. What sense can we make of this? Particularly when we know, for example, in the case of working memory, is that it's really closely related to learning. The problem is that working memory problems are found in all of these different groups, on average. So what does research look like in this field? So research typically consists of group studies where individuals recruit one group, which is, let's imagine it's a group of children with reading difficulties or dyslexia, and they exclude possibly children who have other co-occurring conditions, which probably accounts for 30 to 50% of those children who might also have ADHD, or they might also have language-related problems, or they may also have dyspraxia. So what we're ending up with is kind of a very kind of pure and rather rarefied representation of children who have reading difficulties. They don't probably represent, on average, the average children who are much more frequent and easier to recruit than this rarefied group who you exclude many different children from. And then we compare them with a group of children who are typically developing in all respects. The trouble is that this doesn't tell us an awful lot about the typical child who's out there struggling in the classroom. Well, it certainly doesn't tell you about all of the children. It probably doesn't even tell you about 50% of the children who are struggling with reading difficulties, because they wouldn't have been recruited, they wouldn't have satisfied the selection criteria. Alternatively, sometimes researchers, and I've adopted both these strategies myself in my time, select on the basis of, say, reading or a dyslexia diagnosis, but just don't take into account whether they have these other diagnoses, whether they have problems relating to language more generally, whether or not they have attentional problems of ADHD. So in that case, you've got a broader group than you might be actually interested in, and you don't know whether, if you get group differences, it's due to the co-occurring conditions or whether it's actually due to what you think you're looking at, which might be reading difficulties or dyslexia. So it might not be too surprising that you get a jumble of research findings. Different lab groups use different criteria, they select from different populations. It's very difficult to actually get hard and fast findings from this field. So that represents a real challenge for research into the causes and also the symptoms or characteristics of these conditions, because we've just got jumble in there, lots of different types of kids. More importantly, or as importantly, because it's the first is the critical first step, is that it means that it's pretty much impossible to tailor support to meet the individual needs of a child. So if we take a child who has problems with reading, also has really significant problems with attention, and is hyperactive or impulsive too, then how do we go about supporting that child? Which one of these problems do we focus on? We don't even know about one of them in many cases, because you get one diagnosis and often the child sticks with that one diagnosis and doesn't necessarily go on and get another. So it's a bit of a mess. It turns out this is exactly where psychiatry was probably 15 years ago, maybe 20 years ago. And so what was their solution, and could we steal from it? And the answer really is yes. So instead of relying on conventional ways of classifying and recruiting and conducting studies, what we can do is adopt a transdiagnostic approach. That is, provide a broader focus which looks actually at those features and characteristics like working memory, like sustained attention, like hyperactivity, all these different elements that we can see in children's behaviour. They're real things, and of course they do actually affect the children's performance. We can focus on these and just put to one side any knowledge that we have necessarily, or not be guided by it directly, according to whether or not they have a diagnosis or not, and if so, what the nature of that diagnosis is. So can we cut out that top level and just try and understand the patterns of cognitive and behavioural challenges that we can see or assess that their child's facing, and provide a characterisation of that can then be used in a systematic way to guide support for the child and help everyone understand exactly what the issues are at hand. And I would argue that one of those is that when we might think that children are being inattentive because they're not listening, it's probably actually because they've got working memory problems and they can't actually hold that information in mind. So that was really the experiment that we launched ourselves into about 10 years now, as Duncan said. Did this very closely in collaboration with Duncan, who's still working and is curating this particular cohort, and also Joni Holmes, who's been at today's meeting but has had to go back. So what we did was we tried to set out doing research in a proper transdiagnostic way. We weren't the first people by any means to talk about transdiagnostic approaches to neurodevelopment, but it was all based on just drawing inferences from group studies where there would be a group of dyslexics or children with mathematical difficulties or children with ADHD, and then comparing their characteristics, but not really knowing whether or not there were co-occurring problems across these different groups. So inferences have been drawn, but we decided that what was important was actually to go about recruiting a population of children who we knew were encountering some sort of challenges in the classroom, but we weren't trying to impose any restriction beyond that. And we tried to represent the population of children out there who are struggling. What could we learn from them? So, what we did was establish the CALM Clinic. Obviously, we started with the acronym and worked backwards. So we established the Centre for Attention, Learning and Memory at the Cognition and Brain Sciences Unit. And all this work, well, it's underwritten really by the Medical Research Council very, very generously. So over a very small number of years, we were able to recruit 800 children who came through this particular project, aged 5 to 16 years, mainly at the lower end of the age range. So the children were on average 9 years of age. What was different was that in this study, we recruited children who a practitioner who worked with the children, and they could be any practitioner. So it might be a teacher, it might be a SENCO, it might be a clinical psychologist, a speech and language therapist, it might be a paediatrician. If any of those thought that particular child was experiencing problems with attention, learning, and or memory, then they were admitted to our study. So we didn't operate a high bar. We were just interested in those children really who weren't thriving sufficiently to have come to the particular special attention of any of these professionals who might be working with them. So we were adopting needs-based recruitment. So we wanted children who appeared to have some needs in these areas rather than diagnosis-based, as in many studies. Okay, we did actually collect information on whether or not the children had particular diagnostic profiles. Did they have diagnoses? Were they getting special attention in various different ways? Of the 800, 40% reported that they had received diagnoses. That means 60% didn't. Of the diagnoses that were reported, there were 26 different diagnoses. So almost every diagnosis you can imagine. We did actually exclude any relating to sensory problems or more general learning difficulties, but we had a very, very wide range. The most frequently reported diagnoses were ADHD, dyslexia, and ASD. We might expect to have a high representation of ADHD and dyslexia, given that we said we were interested in attention, learning, and memory. And in fact, about 25% of the children did have ADHD. We had quite a few children with ASD, but typically they had that at the same time as having another diagnosis related more specifically to learning. So they tended not to be children who had ASD alone. So what we did, so we've got a huge amount of data now, we've got 800 children. What we wanted to do was to find an alternative way of understanding the data that didn't depend on categorizing the children into silos. So we carried out detailed cognitive assessments, we took behavior ratings, and we also looked at aspects of brain function, and we took blood tests that allowed, saliva tests that allowed us to look at genes too. But really, what at the heart of it was just looking at, from my perspective, cognition and behavior in these children. Could we understand what the crucial indicators were that would relate to meaningful outcomes in the children's lives, that is, functional outcomes? So it might be how they were doing in reading, it might be how they were doing in maths, it might be whether or not they had mood problems, for example, which were also sampled. It might be whether they had problems in general aspects of communication, social pragmatic aspects of communication. Were there any simple rules or laws or relationships that we could uncover in this most heterogeneous, most mixed sample of children? It was very clear. If we looked at the cohort as a whole, we found elevated levels of difficulties in almost everything we looked at, behaviour, mood, learning, cognition. They weren't necessarily hugely elevated levels, and not all children showed any or a specific mixture of these problems. So there's huge variability. Interestingly, when we looked at their cognition, their behaviour, their mood, they were pretty much unrelated to the practitioners who'd actually referred them to us, to their classifications of their cognitive profiles, their attention, learning, or memory problems. So they didn't relate. Also, when we looked at the different classifications, in many respects, we couldn't really distinguish between the children in terms of their cognition and behaviour in a very clean way. So, however, what we did was we were interested in looking at dimensions, the next level down that I talked about, looking at the characteristics and the features. So could we look at how they related to the important functional outcomes? And we used sort of dimensional analysis approaches to do that. And we got a far clearer picture. So we found, looking at cognition and behaviour, of particular interest are 4 different dimensions. Verbal aspects of cognition, so for example, verbal working memory, also sort of phonological processing. Spatial cognition, so ability to solve abstract problems, for example. Inattention and hyperactivity are those two indicators, those 2 dimensions of ADHD. So each of these, we got huge amounts of variation in each of these. So let's have a look now at outcomes that we were interested in. Reading and maths, communication, peer relationships, and mood. What did we find? Well, if we look at reading, we got very clear and very strong links between how the kids were doing in reading, their verbal cognitive skills, and the extent to which they were inattentive. So children who were doing relatively poorly in reading were relatively inattentive and weaker in verbal cognitive skills. The children who were struggling in maths tended to have problems with spatial cognition, the mental manipulations, and we're also inattentive. If we looked at more social aspects of communication, we found that there was a very strong link with hyperactivity and impulsivity. So elevated problem behaviours in these areas were related to communication problems to some extent, to difficult peer relationships, and also to some mood-related problems. This draws on a large amount of research, and I will give you references and actually mention some of the key collaborators and investigators behind this. So what we found was some clear dimensions, we found some clear outcomes. So that's really where we've got with that particular group. I want to tell you just very quickly 2 other things. I'm running out of time, but I have been told that I could maybe gain 5 minutes at the end if necessary, and I think I'm going to invoke that. One is, it's really clear that it's important that children, we have the information that can actually guide, and the understanding that can guide and enable children to play to their own strengths. So I've been talking so far about areas of weakness, areas of difficulty, but it's areas of strength really that are vital, particularly as the children become older and in the adolescent years. So it's really important to understand these, because it's a way of equipping the individual, the learner, with the strategies for them to succeed. So we've been involved in some work looking at university students who have had classifications of dyslexia. What we find is that they choose their courses wisely. So if we look at their cognitive profiles, then those with verbally related working memory type problems tend not to be found in humanities departments, in history, social sciences, politics, or whatever. But they do tend to be found and quite highly represented in science departments. And that's often accompanied by really quite reasonable strengths in spatial aspects of cognition. So when we asked them how they managed to do so well, to get to university in the first place, to be progressing reasonably, to still be in there, what they describe is actually having a whole set of strategies and approaches that directly address their areas of strengths. So, for example, those individuals who've got verbal working memory problems tend to use techniques such as mind maps and other ways of actually visualizing and reorganizing information. And they're the individuals who are strong in those areas. So we need to know about strengths as well as weaknesses if we're going to help the child as they become older, and they have to be a self-guided learner. So the last thing really I want to say here is that what is really important to me is that we use this information if we can for sort of general benefit. One of the big worries, as many of you will know about, is the support that kids receive in school, is that it can often be influenced by the background of the family, of the school, of the child. And so it's a source of really quite large inequalities in access to support. So many disadvantaged members of the community just don't get the support they receive when they're in school. The answer, one of the important answers, this has been recognised in Parliament at the moment. We have strong support for this particular proposal from Parliament, is to undergo universal early screening across all state schools for the risk of later underachievement. We're recommended that it's going to be led by a teacher, and it's based on partly on their evaluations, their knowledge of the child and how they're behaving. Remember, we can actually detect working memory problems just from behaviours, so we can actually make it relevant to the teachers. We're planning to develop the screener with teachers, families, and those with lived experience, so it will be co-produced and co-designed. And we'll be assessing the cognitive skills, not just how they're doing in learning. In fact, we're not going to be measuring learning directly, but the cognitive skills that you need that we know are important for learning. And we're hoping that this will then provide profiles of strengths and weaknesses that can be used on a systematic basis to inform classroom support and interventions and assessments where needed, to start equipping the child and working with the child in self-guided learning. And also, it should be a great opportunity to share information between schools and families, and that's been recognised as one of the major areas in which we need to develop. So we haven't got funding for this yet. We put the application and the deadline was midnight last night, so we've actually got a long wait. But we think it's an important way that we can actually use what we know about the children for potentially universal benefit. Looking to the future then, what have we learned? Diverse methods are needed to understand neurodiversity. This includes the way we find the children that go into our studies. That's really important. We need to use qualitative as well as quantitative. We need to listen to and engage the experts. We need to support individualized support, so using profiles, not diagnoses or deficits. We need to use research to reduce inequalities wherever we can. To promote sort of fair and optimal outcomes for all children, and promote partnerships where we can. And I'm very sorry for running on for so long, and thank you for keeping your attention. It's been great speaking to you. Here are some of the people that I need to thank, particularly Duncan and Joni, and the Medical Research Council, and all the practitioners, children and family we've worked with. Thank you.